Good morning all of you. In the previous class we have discussed about three-dimensional geometry. Under three-dimensional geometry we have discussed that how to locate point in three-dimensional space and how to find distance between 2 points in 3D space. Now today we will discuss about the section formula. There are two types of section formula. First, internal division and second, external division. First is internal division. In this form of section formula, we have to given 2 points. Suppose that first point A, whose coordinate is x1, y1, z1, and second point B, whose coordinate is x2, y2, z2. Okay, and we have to find the coordinate of point P, which divide the line AB in the ratio m1 is to m2. Okay, we have to given 2 points A and B. Joining these 2 points, we draw a line AB in which we have to find the coordinate of this point, which divide the line AB in the ratio m1 is to m2. So what will be the coordinate of this point P? The coordinate of point P is given by m1 x2 plus m2 x1 upon m1 plus m2, comma m1 y2 plus m2 y1 upon m1 plus m2, m1 z2 plus m2 z1 upon m1 plus m2. This is the coordinate of point P. This is x coordinate, this is y coordinate, this is z coordinate. Okay, now we will see the formula of external division. External division. So the coordinate will be m1 x2 minus m2 x1 upon m1 minus m2, m1 y2 minus m2 y1 upon m1 minus m2, m1 z2 minus m2 z1 upon m1 minus m2. So there are two formula, first for internal division and second for external division. Now we will see some of the questions of your NCERT book of exercise. Let us see. Exercise 12.3. Question number first. Find the coordinate of the point which divides the line segment joining the point A minus 2, 3, 5 and B 1, minus 4, 6 in the ratio first 2:3 internally. we have to given a question in which we have given the coordinate of 2 point A minus 2, 3, 5 and the coordinate of point B is 1, minus 4, 6 and joining these 2 points, the line AB is the joining line. So, and one point P which is divide this line AB in the ratio 2:3 and we have to find the coordinate of this point P. Okay, what we have to given in the question? We have given two coordinate A and B. Okay, and joining these two coordinate we have a point P which divides the line AB in the ratio 2:3. Now we have to find the coordinate of point P. So we know the formula, section formula. This is for internally. Here is clearly written 2:3 internally. Okay, so we will use the internal division formula. What is this? So coordinate of point P is m1 x2 plus m2 x1 upon m1 plus m2, m1 y2 plus m2 y1 upon m1 plus m2, m1 z2 plus m2 z1 upon m1 plus m2. Now this is x1, y1, z1, x2, y2, z2 and this is our m1 and m2. Now we will put all the values from here in this coordinate. Okay, so m1 is 2 into x2. x2 is what? 1 plus m2. m2 is 3 into x1. x1 is minus 2 divided by m1 plus m2. 2 plus 3. Next, m1 is 2, y2. y2 is minus 4 plus m2 is 3, y1 is 3 divided by 2 plus 3. m1 is 2, z2 is 6 plus m2 is 3 and z1 is 5 divided by 2 plus 3. Now we will solve it. We get 2 minus 6 upon 5 minus 8 plus 9 by 5. 6 to the 12 plus 15 upon 5. This implies minus 4 by 5. This will be 1 by 5. This will be 27 upon 5. So this is the coordinate of point P which divide the line segment AB in the ratio 2:3. Okay. So this is our required result. Now we will see next. Second part is it's divide 2:3 externally. Okay. So the formula will be the formula of external division and internal division are nearly same. Just difference is this. There is the difference just of sign. We will change the sign plus with minus, and the formula will be changed in external division. Okay. Now again put the value up. So m1 is 2, x2 is 1, m2 is 3, x1 minus 2 upon m1 minus m2, 2 minus 3, comma, m1 is 2, y2 is minus 4, m2 is 3, y1 is 3 upon 2 minus 3. M1 is 2, Z2 is 6, M2 is 3, Z1 is 5 divided by 2 minus 3. Now we will solve it. 2 minus minus plus, 3 to the 6 and minus 1, minus 8 minus 9 divided by minus 1, 6 to the 12 minus 15 divided by minus 1. After solving we get 8 by minus 1 minus 17 by minus 1 minus 3 by minus 1. So it will be reduced. So it will be minus 8, 17 and 3. So the coordinate of P in case of external division will be minus 8, 17, 3. This will be our answer. Okay. Now we will see the next question. Question second. Given that the point P, Q and R are collinear, find the ratio in which Q divides the point PR. We have to given P, Q and R are collinear. Find the ratio in which Q divides PR. Okay. The point P, the coordinate of point P is 3, 2, minus 4 and Q is 5, 4, minus 6 and R is 9, 8, minus 10. Given that point P 3, 2, minus 4, Q 5, 4, minus 6 and R 9, 8, minus 10 are collinear, find the ratio in which Q divides PR. Okay, so let's solution. So first we will let that this point Q divide the line PR in the ratio K is to 1. We will let it. Okay. Let the point Q divides the line PR in the ratio K is to 1. Okay. So this is K is to 1. This is M1 and this is M2. And X1, Y1, Z1 and X2, Y2, Z2. Now let X coordinate. So X is equal to M1 X2 plus M2 X1 upon M1 plus M2. So X is given. X is what? 5. So 5 is, this is x, this is y, this is z. X is 5, so m1 is k into x2 is 9 plus m2 1 into x1 is 3 divided by k plus 1. Now after cross multiplication we get 5k plus 5 is equal to 9k plus 3. Now transpose it. 5 minus 3 is equal to 9k minus 5k. We can write 4k is equal to 2. So k is equal to 2 by 4. So it will be 1 by 2. Okay. Now y coordinate. Y is equal to m1y2 plus m2y1 upon m1 plus m2. Y is what? 4. M1 is k, y2 is 8 plus m2 is 1, y1 is 2 upon k plus 1. So 4k plus 4 is equal to 8k plus 2. Now transpose it. 4 minus 2, 8k minus 4k. This is 4k and 2. So k is 2 by 4. So k is again 1 by 2. Okay. Now we will find z coordinate. Write the formula. Z is equal to m1 z2 plus m2 z1 upon m1 plus m2. Okay. So z is minus 6. Put the value of m1. m1 is k. z2 is minus 10 plus m2 is 1 and z1 is minus 4 divided by k plus 1. Okay. Now again cross multiply. Minus 6k minus 6 is equal to minus 10k minus 4. Now transpose it again. Minus 6k plus 10k minus 4 plus 6. So 4k is equal to 2. So k is again equal to 1 by 2. So in all case we are seeing that the value of k is 1 by 2, 1 by 2, 1 by 2. So our ratio is 1:2. So the coordinate q divides the line PR in the ratio 1:2. Okay. What we have done? Nothing. We have just used the formula of section formula of internal division. Look at x is m1 x2 plus m2 x1 upon m1 plus m2. We have put the value m1 k, x2 9, m2 1, x1 3, m1 plus m2 means k plus 1. After this we have cross multiplied. Okay. Now it will be 5k plus 5 is equal to 9k plus 3. Okay. It will be after transferring 3 left hand side, 5 minus 3 is equal to 9k minus 5k. So k is equal to 1 by 2. In the same way we have applied here also. Y is equal to m1 y2 plus m2 y1 upon m1 plus m2. And x coordinate, y coordinate, z coordinate are given. We have to already. Okay. In the same way we can also solve. We get k is equal to 1 by 2. Again for the z coordinate we will use it. Z is minus 6. Again m1 is k, z2 is minus 10, m2 is 1, z1 is minus 4, k plus 1. After solving it, we get k is equal to 1 by 2. So the ratio is what? 1:2. Okay. Next question. Question number 3. Find the ratio in which YZ plane divide the line segment joining the point this and this. We have to find the ratio again in which YZ plane divide the line segment joining the point. We have to give it 2 point again. Point A is -2, 4, 7 and B is 3, -5, 8. These are the 2 points, and joining these 2 points, okay, the line AB. Find the ratio in which YZ plane divides the line. This line is divided by a plane, which is YZ plane. And you know the coordinate of YZ, any coordinate in YZ plane is 0, Y1, Z1. In YZ plane, the x coordinate will be 0. Okay. So we will let first the coordinate of, and this line AB is divided by this plane. Okay. So it will be intersecting at some point which is Q. So let the coordinate of point Q is 0, Y1, Z1. Okay, so the coordinate of point Q is 0, Y1, Z1. Now let the point Q divides the line AB in the ratio K is to 1. Okay, this YZ plane divide it in the ratio K is to 1. This is our M1 and M2. Okay. Now we have to again find the ratio. So the coordinate of Q is what? What we have let it? 0, Y1 and Z1. This is X1, Y1, Z1. This is X2, Y2, Z2. So X is equal to M1 X2 plus M2 X1 upon M1 plus M2, where X is 0. So M1 is K, X2 3 plus M2 1, X1 minus 2, again M1 plus M2, which is K plus 1. Okay. Now cross multiplication, we will get 0 in the left hand side, 3K minus 2. So we can write 3K is equal to 2. So K is equal to 2 by 3. So the line AB is divided by the YZ plane in the ratio 2 is to 3. This will be your required answer. Okay. Next question. Question number 4. Using the section formula, show that the point A, B and C are collinear. Okay. We have to show that the 3 points A, B, C are collinear. So, but we have to show that by using the section formula. Okay, so the coordinate of point A is 2 minus 3 4 and B minus 1 2 1 and C is 0 1 by 3 and 2. So we have to show that these 3 points are collinear. So for proving the 3 points are collinear by section formula, first we will let the point C divides the line in the ratio k:1. What we will let the point C is divide the line AB in the ratio k:1. This is our A, this is B. The coordinate of A is 2 minus 3 4 and coordinate of B is minus 1 2 1, and we have supposed that this point C, whose coordinate is 0 1 by 3 and 2, is divide the line AB in the ratio k:1. So what we will find? Now we will find the coordinate x, y, z 1 by 1. So x coordinate is m1 x2 plus m2 x1 upon m1 plus m2. Okay. So x is 0, m1, m2, x1, y1, z1, x2, y2, z2 again. So k into x2 minus 1, 1 into x1, 2, m1 plus m2. Now after cross multiplication we get 0 minus k plus 2. So k is equal to 2. Okay. Now y coordinate, y is equal to m1 y2 plus m2 y1 upon m1 plus m2. So y2 is 1 by 3, m1 k, y2 2 plus m2 1, or y1 minus 3 divided by k plus 1. After cross multiplication we get 3 2 is 6, 6k minus 3 3 is 9 is equal to k plus 1. Now transpose it. 6k minus k is equal to 10. So 5k is equal to 10. So k is 2. Okay. Now the z coordinate. Z is m1 z2 plus m2 z1 upon m1 plus m2. Z is 2. Okay. Z is 2. And m1 is k, z2 1 plus m2 1 and z1 4 divided by k plus 1. Again cross multiplication, we are seeing that 2k plus 2 is equal to k plus 4. Transpose it. So 2k minus k is equal to 2. So k is equal to 2. So we are seeing that the point C divide the line AB in the ratio k:1 means in the ratio 2:1. In the 2:1 ratio, the point C divide the line AB. So we can say that the point A, B, C are collinear. Okay, thank you.